We are in Unit 3, Lesson 3, titled Learning Targets Congruent Triangles. Just to let you guys know, this is a little bit of a longer lesson. There's a lot of important information that you do need to know and understand in order to move forward in this unit. So there will be times where I ask you to pause the video and do some problems on your own. When you press play again, go ahead and check your answers. And if you've got it correct, you can fast forward through the explanations if you want to. All right, but if you do not, make sure you listen and understand why you got your answers wrong. All right, so let's get started. What we're going to be talking about today is congruent figures and congruent triangles. And we're going to learn how we can prove triangles congruent, meaning they're equal measure and size, based upon a few different theorems and postulates. And you'll understand what I mean as we go on. All right, so let's start from the beginning. Let's just understand congruency between different figures. So as we see up here, it says congruent polygons have congruent corresponding parts, which means their matching sides and angles are the same measures. That's what we mean by congruent. So when you name congruent polygons, you must list corresponding vertices in the same order. Okay, so here's what we mean by that. Let's take a look over here at polygon ABCD and EFGH. We are told that these two quadrilaterals, meaning a four-sided figure, that they are congruent. They're the same. Okay, but looking at it, we know that we can tell that certain parts match up with other parts. We can also tell by looking at their names. As we notice here, this one is labeled A, B, C, D. A, B, C, D. Okay, I went around and I numbered the vertices, meaning the angles, and notice how I went in a circular pattern. Okay, I didn't cut across. Now, taking a look at this one over here, if I were to start in the same location, I'd be starting with F. But if I look down here at the name, the first vertex is E. So E is the one that is congruent to A. The second vertex is F. F is the one that's congruent to B. G is third, so G is congruent to C, and then H is fourth. H is congruent to D. So shapes can be flipped around and facing all different directions. We need to make sure that we are identifying them, naming them, and knowing the correct direction so we know which ones match up. So let's go ahead and use this to help us. So the directions say use the figures at the right to complete each congruent statement. So side AB is congruent to what? Well, here I have AB, so I'm going from 1 to 2. So I have EF. Okay, you can also look in the name AB, EF. All right, I have line segment BC. BC is 2, 3, will be congruent to FG, 2, 3. All right, let's do a couple of the angles. So angle A is right here, number 1, is going to be congruent to angle E. Angle B, number 2, is going to be congruent to angle F. Okay, and same thing, they're in the same place in the name. All right, go ahead, pause the video real quick and do the last 4 on your own. See if you can identify. Oops, I forgot my line segments. Pause. All right, go ahead and check out the answers in green. Something to keep in mind. If I were to match up these two figures, meaning flip them so they're facing the same direction, corresponding parts would be on top of each other. Okay, angle A and E would be on top of each other, B and F, etc. All right, so CD is congruent to GH. DA is congruent to HE. Notice the way I'm naming them, order matters. Angle C is congruent to angle G, and angle D is congruent to angle H. Okay, let's continue on. So we're going to use congruent parts now. The question says, if triangle WYS is congruent to triangle MKV, what are the congruent corresponding parts? So here in this one, we are looking at it without a diagram. Now, of course, you can always draw a diagram if that helps you, making sure you label it in the correct order, or we can look at the words. So let's go down to number 9 right here. It says use the diagram from exercise 8 to complete each congruent statement. Sides WY. WY will be congruent to MK. Going in order. All right, pause the video, try the other 5 on your own. All right, and take a look. All right, going in order, going in the same order in both of them. Now, as always, if you have questions or you're unclear, pause the video, try rewinding it, and bring your questions to class. You'll have plenty of time to practice this and ask questions in class. All right, problem 2, finding congruent parts. So the problem says, suppose the triangle WYS is congruent to MKV, so we're using it from above. If the measure of angle W is 62, the measure of angle Y is 35, what is a measure of angle V? So that's what we're going to find out, and we're going to use these next few examples to help us get there. So we're kind of going to deduce how to do that. So number 10 says, using the given information to label the triangles. Remember to write corresponding vertices in order. Okay, so triangle WYS. Well, we've got WY, so S has to go here. And then we have triangle MKV. Now, none of it is labeled, okay? None of it's labeled. So W corresponds with M because they're both the first ones. So W is over here, M is over here. Oops. Why? Because if I were to flip this triangle, this one, flip it that way, they would line up on top of each other. All right, just by looking at it, I can tell that M and W go together. So my next one is K. And K corresponds with Y. Well, Y is up here, so that means K is up here. And the last one, process of elimination, but S and V. So if that's S, this is V right here. Okay, so I have triangle WYS is congruent to MKV. Okay, so 11 says complete each congruent statement. Oops, sorry. Okay, angle W is congruent to what? We just said it. Angle W is congruent to angle M. Angle Y is congruent to angle K. And angle S is congruent to angle V. Right, number 12 says use the triangle angle sum theorem. What that's saying is we know that all three inside angles add up to 180 degrees. So it's just telling us to use that to help us find the missing angle to answer that question from above. What is the measure of angle V? So let's pause for a second and go back before we answer that question. Let's fill in the angle measures. I'm going to scroll up, sorry. So they tell us that angle W is 62. So I'm seeing that right here. So I'm going to pull that in, 62 degrees. If angle W is 62, what's M have to be? 62, because they're congruent. If Y is 35, okay, what's K? 35. So we need to find really S and V. They're going to be the same amount. So it's telling us down here, so now we're going to look at 12. Use the triangle sum theorem. We don't write it out this way, but it's just good to see what we're doing. The measure of angle S plus the measure of angle Y plus the measure of angle W, we know equals 180 because we know all three interior angles add up to 180. So one way to think of it is the measure of angle S is 180 minus the 35 and 62. Okay, and when you do the math, when you add 35 and 62, you get 97. And when you subtract that from 180, you get 83. All right, so the angle of S and V is 83 degrees. All right, so down here we know since the angle S is congruent to angle V, and the measure of angle S is 97, the measure of angle V has to be 97. All right, let's go ahead and flip the page. What should you be comfortable with by now? Identifying congruent parts, labeling, and knowing that they are indeed congruent. All right, so now let's start about talking about congruent triangles. The whole triangle together, understanding how to find and prove that they are. So is triangle ABD congruent to triangle CBD? We need to determine that based upon the information we're given. Yeah, you can look at it and say they look congruent. Okay, I've got triangle ABD, and I've got triangle CBD. So I'm going to say they look congruent, but I can't do things based off of looks because, as we know, images are not always drawn to scale. So we're going to figure out how we can prove this. All right, 14 says, underline the correct word to complete the sentence. To prove two triangles congruent, show that all blank parts are congruent, corresponding. All right, all corresponding parts, meaning all angles and all sides. We have to prove that they are congruent. Circle the name for a triangle ACD. So looking at ACD, which is the whole big guy, what type of triangle is that? If you chose isosceles, you are correct because I see these two hash marks, implying that those two sides are congruent to each other. Number 16 says cross out the congruent statements that are not supported by the information we're given. So things that we can't tell already. So the first one says AD is congruent to CD. Is that true? Yes, here's AD, here's CD. They have the marks, they are congruent. That is good. Let's take a look at the next one, angle A and C. Are angle A and C congruent? Yes, because remember that base angles of an isosceles triangle are always congruent. So far, so good. BD congruent to BD. Well, any line segment is going to be congruent to itself, and we actually call that the reflexive property, which you will learn more about. Okay, think of reflection in a mirror. So if it's asking you if something is congruent to itself, of course it is. It's like twins. All right, angle ABD congruent to CBD. I'm just going to erase these so we can get a better look. Angle ABD, so ABD, we're saying, is it congruent to CBD? Well, they sure look congruent, but do I have any concrete proof? No, I don't. Okay, I know nothing about that angle measure, so I can't say for sure they are. So not true. AB congruent to CB. Are these two congruent? Same thing, they look like they are, but I have no proof. I have no hash marks. I have nothing telling me that, BD bisects it, meaning if it cut it in half, yes, they'd be congruent. But based off the information I'm given, I don't have that. So we can't draw conclusions without concrete proof. And the last one is ADB. So I'll do that one in red. Is that congruent to CDB? Same thing. I'm not given enough information. If they went through and told me that BD, that line, bisects that angle, I could say yes, because the two parts would be congruent. If it said BD bisects this line down here, I could say yes to the others because those two lines would be congruent, but I'm not given that information. So I only have 3 of the parts. In order to prove triangles congruent based upon congruent statements, I need to know 6 of them. I need to know that all 3 angles and all 3 sides are congruent. Right now, I only have half of the puzzle. So for right now, I cannot prove they're congruent based off of what I know. Okay, so here's what we're going to hop into now. We are going to learn how we can prove triangles congruent, given pieces of information, all right, and even given not the whole picture. So we are going to learn six different ways in order to do this, in order to prove triangles congruent. So the first one is the third angles theorem. So what it states, if 2 angles of one triangle are congruent, so if 2 angles are congruent to 2 angles of another triangle, then the third angles are congruent as well. They have to be. So if you are shown that 2 angles are congruent in between 2 triangles, the third ones have to be congruent also. So what that's saying to us, if angle A is congruent to angle D and angle B is congruent to angle E, okay, take a look at the diagram, have the markings. A and D have one little angle mark. B and E each have 2, meaning those 2 are congruent to each other. So if that's true, then we can conclude that C is congruent to F. So I'm going to go ahead and just throw in, this time I'll do 3 as best you can. Okay, so I know that all 3 angles are congruent. So if the measure of angle A is 74, D has to be 74 because they're congruent. If B is 44, then E is 44. And if C is 62, then F is 62. Okay, and I could always check and add them up, and they add up to 180. All right, so let's take a look at our first what's called a postulate. Side, side, side postulate. A postulate is a way to prove something. So what this one is telling us, if 3 sides of one triangle are congruent to the 3 sides of another triangle, then the 2 triangles are congruent. This is our first proving triangles congruent theorem, or I'm sorry, postulate. If 3 sides of one triangle are congruent to the others, those triangles are congruent to each other. Okay, they are. So let's take a look at this diagram. If AB is congruent to DE, and see I have my hash mark, 1 and 1. BC is congruent to EF, BC, EF. And AC is congruent to what? All right, think about the way you're labeling it. A, B, D, E. B, C, E, F. A, C, D, F. You have to go in the same order. So I can conclude that triangle ABC is congruent to triangle DEF, going in the same order. So side, side, side. Let's take a look at these two examples. The question says, are the triangles congruent by side, side, side? Can we prove that three sides are congruent based upon the information we're given? If they are, write the congruent statement. So we'll do the first one together. So right here, I see that MO is congruent to what? Okay, now, pause on that for 1 second. Let's take a step over to the left. Let's identify these triangles. Let's write their names so we know the order we're looking at. So I'm going to label this first one KMO. Really, I could have started anywhere. Just make sure that once you pick a direction, you're going in the same order. So triangle KMO. And then what matches up with K? Okay, well, I know L and M match up, so I know L is going to be in the middle. K is the opposite side, so K and M form that 2 hash mark side. So O and L form that 2 hash mark side. So O has got to be first in this triangle. So it's going to be OLK. Okay, so those are the 2 triangles I'm looking at. So now when I come over here, I'm going to say that MO is congruent to LK. Okay, looking at the way that they are ordered there. I also can say that KM is congruent to OL. Okay, because those have 2 hash marks. Now I need 3 sides congruent in order to prove, using SSS, side, 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 that these 2 triangles are congruent. Well, I don't have any more hash marks, so am I out of luck? Now, in this example, this right here is the same line for both triangles, so we can use the reflexive property. If it's the same line, once again, it is congruent to itself. So I can say that looking at the green triangle, KMO, all right, so I can say line KO is congruent to line KO itself. So I have all 3 sides congruent. So I can conclude that triangle KMO is congruent to triangle OLK. We can say by side, side, side. Because all 3 sides are congruent, the 2 triangles are congruent. All right, go ahead, pause the video, go to the angles or triangles on the right, letter B. Decide if you have 3 corresponding sides that are congruent, and if so, write the congruent statement, which is this down here. So you've got to figure out how to label those triangles. Go ahead and pause. Okay, take a look. Now keep in mind, you may have labeled your triangles in a different order. That's fine as long as your order is staying the same, okay? So I started with A, so I started with the angle in between my 3 and 1 hash marks. So over here, that's going to be L. All right, and then I moved on to P, so in between my 3 and 2, which over here is K, and then the last one. So if you went like P and A, that's fine. Your second one would match that. It would be KCL. All right, so just going in the same order. So I could find 3 congruent sides, so therefore triangle APN is congruent to triangle LKC by side, side, side. All right, so if you're given, once again, if you're given 3 sides are congruent, you can say the triangles are congruent based off of just that. Let's take a look at our next postulate. All right, this one is called the side angle side postulate. Now, side angle side, we're going to need a side, an angle, and another side. So if 2 sides and the included angle of one triangle are congruent to the 2 sides and included angle of another triangle, then they are congruent. Keep in mind here, included. So the angle is sandwiched between the 2 sides. Smushed in the middle. Okay, so of course you may be given more information, but all you need is a side, an angle, and a side. So let's take a look at this diagram. It says use the figures below to complete each statement. Well, first of all, let's look at triangle ABC. What are we given? We are given 3 sides. Am I given any info on my angles? No. How do I know? There's no hash marks or angle marks there. Okay, our next triangle is DEF. I'm given 3 sides and an angle. So in this example, if I were to use side angle side, I would have to use this side, this angle, and this side. Because side, angle, side, they are directly next to each other. There is no break in between. Okay, and then in the last one, STR, I have side, angle, side. So 8 says triangle DEF is congruent to what by side, angle, side? So we already said it's these two triangles that are side, angle, sides. So DEF, okay, so this one's going to be T, starting with T because those are where your angles match. Let me erase the markings so we can see. Okay, so D and T match because that's our angle markings. E is next. E is between the 3 and the 2. Okay, well, we don't have a 2 over here, but we know it's going to probably be that side we're looking at. Okay, so R, S. All right, triangle ABC. ABC is congruent to which one by side, side, side? This one, DEF, because that's the one that has the 3 side markings. All right, pause the video, go ahead and work on the next part. It's just seeing if you can tell which one would be the included, so the one that's sandwiched between, working with sides and angles. Go ahead and pause. All right, go ahead and take a look at the included parts. AB and AC, I'm sorry, AB and CA are right here, so angle A is in the middle of it. Angle A and C are these two angles, so the side in between is AC. Angle or BC and CA right here, so angle C is in the middle. Okay, angle B and C here, so it's line BC, or CB, sorry, et cetera, et cetera. All right, so take a look, pause if you need to, go back and take a look at it. All right, so let's do some practice with side, angle, side. So what other information do you need to prove triangle LEB is congruent to triangle BNL by side, angle, side? So we're going to walk through how you would know this information. So question number 10 says circle the angles that are marked congruent in the diagram. So here I have 2 angles. I have NBL. Always put the vertice, the middle letter, the letter by the angle in the middle. So I have NBL, or you could look at it as N or as LBN, but we have NBL right here, is congruent to ELB. ELB, okay? L has to be in the middle. Then it says circle the sides that form the angles that are marked congruent in the diagram. Circle the sides that form the angles. Okay, so taking a look at angle B right here. I have NB and BL, so we're going to find the ones that match that. So I've got BN, and we said BL or LB. Okay, and then all right, and then I have LE up here for this one. So it's these sides right here. Those form the angles. All right, so it says complete each congruent statement. Side LB is congruent to what? LB, right here in the middle. It is congruent to itself. So therefore, angle BLE is going to be congruent to what? So we got to be careful of how we're naming them here. So BLE is going to be congruent to LBN. All right, so proving triangle LEB and BNL by side angle side requires how many pairs of congruent sides and how many pairs of congruent angles? Side angle side. 2 pairs of sides, 1 pair of angle. The diagram currently shows congruency of how many sides and how many angles. Well, right now we only have 1 side and 1 angle based upon what they give us so far and what we looked at in number 12. So to prove the triangle is congruent by side angle side, we still need 1 pair of sides and 0 pairs of angles. We already have our angle. So to prove the triangle is congruent, we need to prove that, scroll back up, LB is congruent to LB. And we can do that saying they're reflexive. It's the same line. Okay, and we have side angle side. Now take a look. That would be side angle side. Okay, side angle, side. Sorry guys, I messed up on number 16. I apologize about that. We know LB is congruent to LB because of the reflexive property. Okay, we already know that one. We're not given any other information yet. So we know those angles are congruent, and we know that LB is congruent to LB. So we need one more side. Okay, which side is it going to be? Well, we have, let's take a look at triangle BNL. Okay, we've got angle and we've got a side. So we need a side that sandwiches the angle in between. So it has to be this side down here because we go side, angle, side. All right, so for the other one, it has to be this one up here, side, angle, side. So for number 16, we are saying that we need to know side LE is congruent to BN. Because we do know the other one already because it's reflexive. I apologize. So key point, in side, angle, side, the angle has to be sandwiched in between the two sides. Okay, so let's do some practice. Identifying congruent triangles. I want you to pause the video, do this on your own, and you can press play again and check your answers. All right, go ahead and check your work. If you have your answers correct, feel free to move on. If not, pause the video, take a look, and see if you can figure it out. We are given 3 sides in an angle, but we can't use side, angle, side because the angles are not in the same location. Okay, in one diagram, they're between the 2 and the 3. In the other diagram, they're between the 2 and the 1. So they do have to be in between sides, but they have to be in between the same sides in both diagrams. Okay, angle, side, angle, which is different than side, angle, side. So if 2 angles and the included side of one triangle are congruent to 2 angles and the included side of another triangle, they are congruent. So if A is congruent to D, AC is congruent to DF, and C is congruent to F, then we can say that triangles are congruent. So let's take a second and explain how ASA is different than SAS. Well, in angle, side, angle, you have 2 angles on one side, and side, angle, side, it's vice versa. So in angle, side, angle, 2 angles, one side. In side, angle, side, 2 sides, 1 angle. So just the requirement of what pieces you have to prove it congruent are different. So let's do some practice with angle, side, angle. Okay, so which 2 triangles are congruent by angle, side, angle? So let's take a look. In this first triangle, I'm given an angle, a side, and an angle. Okay. In this triangle, I'm given 2 angles and a side also, and so I am in this last one here, CAT. But what is the problem with this one right here? The problem is this side is not included. It's not in between the 2 angles. So that is not an angle, side, angle. The angle's not included. Okay, so number 11 says name the triangles, list the vertices in corresponding order, blah, blah, blah. All right, the first one, GHO. So I went from 1, 2 to nothing. Okay, over here I'm going to do INF. INF. 1, 2, nothing. CAT. Cat. All right, if angle G is congruent to angle I, which is congruent to angle C, angle H is congruent to N, which is congruent to A, HG will be congruent to NI, which will be congruent to AC. Okay, the congruent sides that are included between congruent angles are which ones? They are HG and AC. Okay, NI is not included. So our congruent statement would read that triangle GHO is congruent to triangle CAT, and we can say by side, angle, side. Oops, just kidding. Hopefully you caught me. Angle, side, angle. Because we have an angle, a side, and an angle. All right, guys, so far we have talked about side, angle, side. Angle, side, angle, side, side, side. These are 3 of our theorems or postulates that we use to prove triangles congruent. If you're given that information, you can say 2 triangles are congruent based upon this. And we'll be practicing with these concepts. Okay, we have 2 more to do. I know this is a long lesson, but we have 2 more to do, and then we are done with this lesson, so hang in there. All right, the next one is angle, angle, side. Angle, angle, side. So it's similar to angle, side, angle, where you have 2 angles. However, the side does not have to be included. Okay, so that's the difference. If you're saying they're congruent based upon angle, side, angle, your side is included in between the 2 angles. It's smushed in between. If it's angle, angle, side, they are not smushed in between. All right, so our theorem states if 2 angles and a non-included side of one triangle are congruent to 2 angles in the corresponding non-included side of another triangle, then they are congruent to each other. So take a look at the diagram. If A is congruent to D and B is congruent to E, that's supposed to be an E. Okay. And AC is congruent to DF, then we conclude they're congruent. So the non-included congruent sides of triangle ABC and DEF are AC and DF. Okay, let's determine whether they are congruent. Are PAR and SIR congruent? Explain. So we got to think about this visually because they're kind of flipped around. So our congruence marks show that angle A is congruent to I. PR right here is congruent to SR. Make sure you're labeling in the same order. One thing to show you real quick. PAR, SIR. So going that way. Okay. So what other corresponding parts do we need? What other corresponding congruent parts exist, I should say? Well, what other information do we know, guys? We know that these 2 angles right here are congruent. Let me erase my other marks so you can see. These 2 angles right here. So angle ARP and angle IRS. Why? They're vertical, okay? So we know that angle ARP and angle IRS, and they're vertical angles. And we know vertical angles are congruent. Okay, so do we have enough information to decide they're congruent? Yes, because we have angle, angle, side. Angle, angle, side. So we can say they're congruent. So what theorem? Our angle, angle, side theorem. Not all triangles are going to be congruent. So don't always think that just because you see 2 triangles, they're congruent. You have to decide if you're given the information. All right, last one. This one is called the hypotenuse leg theorem. Hypotenuse leg. Only works for right triangles. So if you do not have a 90-degree symbol, forget this one. All right, so one side of a right triangle is or is not a hypotenuse. Yes, we know it is. A right triangle has how many legs? 2, because the third side is your hypotenuse. The length of the hypotenuse is always equal to, greater than, or less than the length of the legs. Greater than, guys. It's always across from the biggest angle, the 90-degree angle. Okay, so let's talk about hypotenuse leg. So cross out the side in example 7 and 8, or cross out the side that are not hypotenuse. BC. BC is not a hypotenuse. It's tiny. It's down here. Hypotenuse is always across from the right angle. Draw that. AB, yes, AB is across the right angle. GH, yes. FD, yes. We're good. Okay. Circle the legs. The legs are the other ones. AC is a leg. AB is not a leg. That's our hypotenuse. HI is a leg. And ED is a leg. Okay. So hypotenuse is across from 90-degree angle. Legs are the other sides. So our last theorem, the hypotenuse leg theorem. If the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent. Okay, so it's kind of like, nope, never mind. So if PQR and XYZ are right triangles, and PR is congruent to XZ, that's your hypotenuse, and PQ is congruent to XY, then they are congruent to each other. So you need one leg and one hypotenuse. You can't do this with 2 legs, meaning you can't do it with the 2 sides There, just you need to know a leg and a hypotenuse. And obviously it has to be 90 degrees. So, to use a theorem, the triangles must meet 3 conditions. Complete each sentence with right or congruent. So there are 2 blank triangles. We need 2 right triangles. The triangles have hypotenuses, congruent. I'm going to write the symbol. The hypotenuses have to be congruent and 1 pair of congruent legs. So this is a bare minimum that you need, okay? The angle, the hypotenuse, and the leg for a right triangle to prove them congruent. All right, we are done. This lesson is long and there's a lot of new information, so it may be a little confusing, okay? Go back through and maybe watch a couple of the parts that you still need some help on. What you should be bringing to class is being able to name triangles, find corresponding parts, and be familiar with the titles: angle, side, 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 angle, side, hypotenuse, leg, side, angle, side. All right, we will do more practice. We'll do lots of practice with this in class. So you at least need to bring those acronyms with you. Know those acronyms, and we will really go over what they mean. All right, nice job. We are done.